Hey everyone, my name is Nathan Ingram, and I'm a senior editor at Engadget.com. And with me today is Chris Lewicki. He's the CEO of Planetary Resources, and he's got something really cool to show us today. Chris, for starters, can you tell everyone about Planetary Resources, what your mission is, what you guys are trying to do?
Yeah, well, absolutely. Very excited to be here today. Planetary Resources is an asteroid mining company. And our goal is to expand the economy of humanity into space through the use and the pursuit of resources.
So when you say the economy, what do you mean by that?
Well, everything that we know here about on this planet, involves making stuff, using stuff, energy, fuel, oxygen, the air we breathe. It's all because of everything that we have here on this planet. But when you get into space, of course, you need a spacesuit or a spaceship to be able to support all that. But if you could use the materials you found on space, say, for example, from an asteroid, and use that to build things, to create the oxygen you need, maybe even to create the rocket fuel that goes into your spaceship. This is actually how we are going to move into space and develop the next Vegas Strip in outer space.
So yeah, when you say move into space, what do you envision there? Like, are you thinking colonies off the planet?
Oh, absolutely. Humanity is destined to be a multi-planetary species. Earth is really just the place that we got started. We've seen great successes with SpaceX and with Blue Origin launching their rockets and landing parts of them back on the surface and reusing those. But everything that we ever send into space, at the end of when we're done using it, gets thrown away. We don't actually reuse or recycle this stuff because when it runs out of gas, there's no gas station to refuel it. So that's what we're talking about creating. So if we want to get off the planet and we want to have space hotels or go to Mars or really just have another place, should something bad happen here, this really is our future and something that we're working on every day on.
I feel like it's probably worth noting, though, that you're not advocating we abandon Earth, right? We're not going to
no,
just
absolutely not.
use up the planet and leave, right?
No, this is it's a wonderful place, and the best place to preserve it is to take our business and continue to do what we've always done, and expand and grow and thrive, and just make space a part of the place that we live and operate.
And is it fair to say that asteroids are almost essentially a unlimited resource?
There's an infinite amount of resources in space. There's tens of millions of asteroids, and the Earth is just a crumb, really, of everything that's out there in the universe, really. So this all sounds like sci-fi, but it's stuff that we're actively doing today and is going to happen very soon.
Well, can you talk, then, in that case, what's out there on these asteroids that you seem to find so compelling and that could be so useful to us, both on Earth and if we're trying to move off the planet?
Well, I'm sure many of the people that follow Engadget probably have heard about asteroid mining before and have seen the headlines about, trillions of dollars of platinum and platinum group metals and these very rare and very useful materials. And those are absolutely on there. They're actually measured in these meteorites that land on the Earth. So that is a very useful material that we could actually get and bring all the way back to planet Earth. But that's probably in the perfection of the industry. What we're going to go after first is something very simple. It's very simple, and it's water. Oxygen, hydrogen, H2O, and water, of course, is important for you and I to live, to drink. The oxygen you can breathe, and hydrogen and oxygen are actually rocket fuel. So that is on carbonaceous asteroids. That's actually how things all start. But kind of the next step, after you've gotten your refueling station, your gas station, so to speak, in space, then you want to start taking metals off asteroid, iron, nickel, cobalt, and using those to build things in the same way that we've built things, when we first came to the Americas, when we first came to the West, we built things using local materials, and we're going to use the metals and asteroids to do that.
So it's not entirely different than mining on the planet and taking those resources and building things on Earth as we do now. You're just thinking of doing it out in space, getting resources from an asteroid, bringing them somewhere where we can build, and then using the parts as we need to out there.
That's exactly it, Nathan. And we could actually ship all this stuff from Earth, put it on a rocket, but it costs tens of millions of dollars for every ton of material. So, to build a car, for example, would cost $100 million in shipping costs. So this is why, if you can just get the material out there, you don't need to pay for the shipping. And this really is what is going to be required to live and operate in space long term.
Do you think it would make sense at all to find resources out in space and send them back to Earth? Is that something you envision as well?
Well, quite possibly. As I mentioned, things like platinum and the 6 platinum group metals, iridium, osmium, those are really cool elements. They're really expensive elements because on the Earth they're very, very rare. But actually in space they're pretty abundant. And if we could get them from space and bring them back to Earth, we now can actually start using those things in a lot more places because they become cheaper.
So it could be a two-way street.
Yeah, absolutely.
Yeah.
And in the same way that we have shipping and commerce going on between all the different countries and continents here on Earth, our vision is really to have space just be another one of those places. And we get what we need, and we send stuff there that we need to send. And just like the economy works here on Earth, that's how we're going to move it into space.
And you mentioned fuel, so from the water that we can get from an asteroid, you envision being able to use that as a basis to make rocket fuel and make it easier to refuel ships. I mean, I guess I shouldn't even say easier, make it possible to refuel ships.
Yes. Yeah, and so every space shuttle that ever launched, all 135 of them, if you remember that big orange tank was filled with millions of gallons of oxygen, liquid oxygen, and millions of gallons of liquid hydrogen. And if you burn those two together, that's the best rocket fuel there is on the periodic table of the elements. And to be able to get that into space and use that, kind of imagine if you had to fly your airplane from Las Vegas to New York, and after you land, you throw away the airplane. Because
huge waste.
Yeah, because it ran out of fuel. There's no gas stations. You can't refuel it, so you got to ship out another plane from Las Vegas. That's how we explore space today. And if we were able to have fuel in New York when the plane lands and refuel it, that plane can go somewhere else. And we don't yet have that in space, and that's what Planetary Resources is looking to create.
And then the last thing you mentioned was the metals that you can get besides the sort of platinum group metals, iron and so forth, correct? And that, I think, brings us into what you want to announce today. Is that accurate?
Absolutely, and this is something...
Let's check it out then.
We're very excited about this. So we're talking about resources from space, we're talking about metals, manufacturing, and we have actually, for the first time on planet Earth, we have 3D printed an object made from metals obtained from resources in space.
So to sum that up, this is a 3D printed model, basically, and it was made from a meteorite that was found here on Earth, landed billions of years ago, I believe.
A few million years ago.
A few million years ago, yep. And this is half of it right here.
Yeah, this is actually the meteorite that this object came from, and we have a partnership with 3D Systems, and we use their ProXD direct metal printer 320, which you can go see in the 3D Systems booth, to take this material and print out an object. And this object came from a meteorite, came from space. And this is technology, this is the manufacturing technology that we'll use in space, kind of like the Iron Age in space, because this piece actually is, a little bit iron. So this is going to transform, really, manufacturing, 3D printing, aerospace technology, and the way that we explore and develop our frontiers in outer space.
So we need to mine the resources from asteroids, then we need to build things with them. This is our first proof that we can, in fact, build things with metal from an asteroid.
Yeah, first time ever in history.
Can you tell us about the process then? How do you take a rock like this and then turn it into something that you can use to put into a 3D metal printer and make an object?
Yeah, well, in manufacturing in the present day here on planet Earth, what we do is we take metals like this and in a vacuum chamber, we heat them up, melt them, and then essentially spray them into really fine particles. And we did this with this meteorite material. And with this powder then, we use a direct metal melting process to create the powder that we can then use the printer for 3D printing. So that's how we do it on Earth today. In space, though, actually, some meteorites, carbonaceous chondrites actually, already have really fine particles of iron in them. So when you're done extracting the fuel, the hydrogen and oxygen, what's left over, you could actually rake out the metal particles that are in there and 3D print objects from them. So you can create the fuel and then the fuel tank.
So it's almost
from the same asteroid.
I don't want to say recycling, but instead of creating the water and making the fuel and having waste left over, you're able to actually take that waste and use that to build useful things.
Yeah, and this is the future of construction and building in space, and this is why asteroids are really so important to the future of civilization, I think. So it's very exciting technology, and we're happy to be at the forefront of it with 3D Systems.
So Obviously you made this on Earth, so it's not terribly different than what we do here now. What are the challenges involved in getting to the point where we can have a machine like you used, like the 3D Systems printer, up in space somewhere? How does that change things?
Well, one big challenge, and you'll notice this if you go look at the printers, is they have these big chambers, and they have to pull all the air out, and they create a vacuum, and big pumps, and cryogenic purges, and all these types of things to create, essentially, what is the environment that exists everywhere in space for free. So we don't have to do that part in space. Okay. It's just that way.
So there's a little bit of a benefit. There are some things we talked earlier, and you said there are some things about working in space that make this easier and make there's different rigors that the parts have to go through that maybe will change, right?
Yeah.
Lack of gravity, so forth, makes it easier, in fact, to do some of these things.
Exactly. So, in this case, we don't have to have this big chamber. We can actually just, kind of do it outside the airlock. Don't even need a container for it. So that's the part that's a lot easier. I think the stuff that we still have to do a lot of work with, of course, is there's no gravity in space. So, the print bed and which way is up and which way is down, that doesn't exist in outer space. So being able to innovate and create the technologies that allow us to process these powders in the absence of gravity, I think is in some ways a challenge because we haven't done that yet. Yeah. But I also see it as a huge opportunity because now you're not limited by how big of something you could print. I can just keep printing, for a meter, for 10 meters, for a kilometer. The print volume and the chamber size is infinite.
Yeah, we really have to think about it. Forget all the conceptions and the notions we have of how things work here on Earth, right?
Yeah. Yeah, so it's every company that's involved here at CES today is talking about print volumes and how big of parts they can print. So, the solar system is the limit in space.
Yeah. Okay. So, and also when we initially talked about this, I was like, how do we know that we can make something that can withstand the rigors of space? And you mentioned something along the lines of, well, there's a lot of less stress up there, and we don't have to send things up in a rocket like we do now, which is also another stressful environment. Am I getting that right?
Yeah, so if you've ever watched a launch or looked at an astronaut camera view or, watched some of the movies, a rocket launch is a really, really, really violent thing. It's loud, there's a lot of shaking, there's a lot of G-forces, and you have to build your spacecraft or your Mars rover or your space telescope.
Or your 3D printer.
Or your 3D printer to be able to go through that really, really violent ride. It's like worse than a shipping company would ever do to it. Your part that you're building, your aerospace part, has to be built for those 9 minutes of its lifetime. But in space, you have this wonderful, very, very, light, very, very pleasant environment of microgravity where you could have stuff that's paper thin and a mile long, and it'll be just fine. So the way that we can engineer things and create things, if we can actually make them in space, is really just going to change everything.
So again, it just totally changes our preconceived notions of how things need to be manufactured, not just take out the equation of having to send them into space. Right now we can't make something that's paper thin and a mile long and not have it fall apart.
Yeah.
But up there we can
no problem at all.
Very different things.
Yeah, so there's with an infinite amount of resources, there's really an infinite amount of possibilities of the different things we do, and this is where science fiction starts becoming science fact, and how we actually create reality. This is how the Starship Enterprises of the future will be printed, or pick your favorite spacecraft from Star Wars.
What the hell is Star Wars? I haven't heard anything about it.
Know nothing about it.
All right, well. Moving on from that, so what needs to happen between now and this future where we can do this? How do you see this technology improving? What milestones do we need to hit where we can get to the point where we are able to print things in space?
Well, today Planetary Resources is working on technology that's going to allow us to go out to space, to a near-Earth asteroid, and confirm where we should start, where we get these resources from. We launched our first satellite last year from the International Space Station. We're demonstrating all sorts of cutting-edge commercial technologies for space exploration. Our next satellite, the Arcad 6, is being prepared right now to be launched later this spring. It's going to have on it the world's first commercial infrared camera, and we're going to be able to take pictures not only of asteroids, but of our own planet in the infrared and create information about the resources here on Earth.
So you're working on technology that can benefit us on Earth right now, in addition to once we get out of space. Is that fair to say?
Absolutely. One step at a time, kind of building on each success. A lot of the ways, like different versions of software are released. And this is what technology allows companies like Planetary Resources to do today. With a small team of people in Seattle, Washington, we can do what it used to take a government agency 20 years ago. So this is something I'm very excited to be here at CES. And really all the technology that we see around us is transforming the way that we're able to both explore and move into and develop space.
That's really fascinating. Well, I think we're just about out of time, but I want to say thanks very much, Chris, for coming over here. And for everyone who's here at CES, 3D Systems has a booth over in the Sands Expo Center. It's booth 72721. You can see the 3D printer that was used to make this print. It's out there. It's massive. It looks like a huge bank vault, and it's really cool. And you'll also be able to see the print itself, I believe.
Absolutely. And for everyone out there who's watching, everyone here at CES, Planetary Resources is a small, very fun company to work at. We're currently hiring, looking for brilliant people who want to change the world. Go to our website, planetaryresources.com. Come check out the booth with 3D Systems, and just very excited today to be able to say that we are making material out of and making structures out of alien material obtained from asteroids.
And if you want to see more from this part and hear more about the story, how it was made, go to Engadget.com today. A story just went up with photos and all sorts of news about this. So thanks everyone for checking this out.